Hey everyone, it's Max here with UCSB Physics Circus, and today we're in the Garden of Science to do a fun at-home experiment to explore surface tension with just objects that you have in your house. So you may have heard of surface tension before, and the fact that it is the property that water wants to reduce its surface area, but how does that actually work exactly? Well, really the idea is that water is made up of a whole bunch of molecules. Like in any water glass, there'll be many millions of billions of molecules of water that are all quite attracted to each other. So when you put a whole bunch of water molecules in a group, they all want to clump to the center and be near to each other, which is why you often see water forming drops, like in raindrops or drops on a surface. However, in the case that you have a whole body of water, like for example a swimming pool or water in a glass, and you have a surface, the property of surface tension actually means that water can almost have like a skin that you can rest things on that would normally sink. So for example, I have a paperclip here, and it's actually made of metal. And so ordinarily, this paperclip should sink when I put it in a glass of water. However, if you put it in just right, you gotta be careful here, on the surface, the paperclip actually floats. And so this is due to the property of the water that in fact, the water molecules on the surface are being pulled into the center, and therefore they form a kind of barrier on which the paperclip, which is normally denser than the water, can usually, which would usually sink and float. And so you can see here, and the Bethan is pointing out the camera angle, if you look at it just right, you can actually see the surface of the water is bending to accommodate the weight of the paperclip. But another cool way to see that is here. Like in the scientific documentation we have for this experiment, it says you might want a white piece of paper. Here's why. If you take your trusty flashlight of science and shine it above the paperclip, you see that it actually forms a really interesting kind of bulbous shadow. And what I'm gonna do here,
I can hold it.
Okay, is actually, no, here, I got it. Is if you actually hold the paperclip down and then look at what kind of shadow a normal paperclip makes when it's near the surface of the water, you see that it's actually much more well-defined and resolved than the paperclip that's floating that you see right here. And once again, that's because the surface of the water is actually bent under the weight of the paperclip, just like as if it were some kind of plastic screen or something that the paperclip is sitting on. And another interesting thing about surface tension is that it can actually be destroyed pretty easily using things that you just have in your house. So if you've ever used hand soap, which I think a lot of people have been recently, hand soap actually contains things called surfactants, which actually destroy the surface property tension of water. So the surface tension property of water. So when you have the water molecules that all want to be close together, what a soap molecule does, or a bunch of them, will actually get in between the water molecules and destroy the attraction that they have for each other, almost it. So if I were to just put a little bit of soap on my fingers, rub around, and then put it in near where the paperclip is, you can see that all of a sudden it actually sinks all on its own because the soap molecules begin to distribute themselves around the surface of the water and destroy the attraction that they have, breaking the barrier. And now you can see that the paperclip no longer floats. And one way that you can actually visualize this is check this out. We're gonna head over to the trusty trampoline of science and hop on. So you can see here that before I've stepped on, the trampoline surface is actually entirely flat, just like the water in the glass before I put the paperclip on. However, as soon as I climb on, you can see that it actually bends under my weight because it's now got all this weight to support, and so that's why it begins to get curved. And you can see here, Bethan showing underneath, that actually as I begin to bounce, that becomes even more exaggerated. And so soap in the analogy would be something that effectively dissolves this entire trampoline tarp and wouldn't be able to support me anymore. So that's what surface tension is, and this is what it looks like on a big scale. And this has been Physics Circus. I hope you had a good time. Bye everyone.